Hello everyone, I'm Daniel Tanjin Kai. Today I'll be sharing with you my QUAS Project presentation. Here is a brief look of what I'll be going through in the presentation, including the earthquake data and the drunk driving data, with each of their tests being performed. So to start, I would like to discuss whether a percentage or subset of the earthquake's data follow a Poisson distribution based on my chosen time and region. In order to conduct my test, I first have to construct my null and alternate hypothesis. The null hypothesis being that earthquakes do indeed follow a Poisson distribution at a 5% significance level, and the alternate hypothesis being that they don't. So to start, I need to filter based on my country of choice, being Indonesia, since it had the greatest quantity of values available. And once that was done, I had to calculate the occurrence count for each state, which means the number of earthquakes that happened per day. Then I had to find the remaining days not accounted for in the data set, which meant that 0 earthquakes happened that day, and find their count. And to do that, I also had to choose my subset of end dates and start dates, as you can see from the right. Now that I had all of my frequencies, I could compute them in a table, as you can see from the right. And from there, I could find my lambda, or mean, based on the equation above. Once I had my lambda, I could calculate my Poisson probabilities and then find my expected frequencies, which, to do that, meant that I had to calculate the sum of observed frequencies and multiply it by the corresponding Poisson probability. From there, I could find my chi-square test statistic after computing my chi-square values past the rule of thumb, where I had to merge adjacent expected frequencies with low values. And as you can see, the chi-square test statistic is about 90. What was left to do was to calculate my degrees of freedom, which was taken by my final number of categories minus 1, being lambda, the parameter I had to find, and minus 1 again, which left me with 1. And to compare the chi-square test statistic and the chi-square critical value, you may refer to the diagram on the bottom right. In the end, I rejected the null hypothesis based on my findings and concluded that it does not fit a Poisson distribution at a 5% significance level. Moving on to drunk driving, I wanted to see if the gender and the state of drunkenness in a subject had any statistical relationship with each other at a 5% significance level. And to do it like the last process, I had to form my null and alternate hypothesis first. So the null hypothesis being that gender and drunk are independent from one another at a 5% significance level, and the alternate being that gender and drunk are dependent on one another at a 5% significance level. So to start, I had to perform random number generation by taking a value between 0 and 1 and assigning it to each value present in the data using my last 5 digits as the random seed, then sort them in descending order and find the first 500 rows. From there, I could calculate my observed frequencies and totals for each category. And next, once I had my totals, I could find the marginal probabilities. And from my marginal probabilities, I could calculate my expected frequencies, as you can see from the bottom right. What was left to do was to calculate my test statistic based on my values from the observed frequencies and expected frequencies from the equation shown on the top right, and that left me with approximately 2.31743 as my chi-square test of independence test statistic. To explain briefly how the test statistic equation works, we need to find the difference between the observed frequency and expected frequency, square that value, and divide it by the expected frequencies. Once we have done that for each corresponding category, we need to find the sum of all of them. And that would be our chi-square test of independence test statistic. I also had to calculate my degrees of freedom, which was by taking the number of categories minus 1 each and then multiply it with one another, and I got 1. From there, I could then calculate my critical value and compare it with my chi-square test of independence test statistic as calculated previously. And finally, I had no choice but to accept the null hypothesis and conclude that gender does not have a statistically significant relationship with whether the subject was drunk at a 5% significance level, meaning that they are independent from one another. And that concludes my presentation. Thank you for watching.